Good morning. I hope that you are doing well. This is the first stream for 2025, and I am very excited for what this year holds. And I hope that you all had as wonderful of a holiday period as I did. I didn't get nearly as much work / Jugglebot stuff done as I was maybe hoping to, but honestly, I think that was kind of a good thing because I had a very good time just kind of hanging around, seeing family, doing holiday things. But now we are back, and I have some very exciting updates to share with you all. I know that I say that every time, but I feel like it is actually exciting for me every single time, which is good, I guess. So the first update that I have for you all is one that I'm very surprised by, which is that the black marker caps are working. And what I mean by this is that you may recall that I have some tracking markers that are similar to this but much smaller on Jugglebot's base, and my cats are very keen on munching on these, and I really don't want them to be munching on these because they're pretty expensive and I don't want them to move around at all. And so I made these caps to go over them, to protect them from the cats and also to cover them up for other sequences. But these caps were white, and my cats, for whatever reason, were just in love with these white caps and would just whack the caps off and then go, haha, there's a nice little ball in here, and then they would munch on the ball. I was not really sure of how to fix this, but my partner had the suggestion that maybe making the caps black would help. And so I have these under here. That's one of the, oh, I'm on the wrong one. I've got a camera update to share with you all as well, but yeah, so under here there's these markers, and these caps go over the top and cover them up. And surprisingly, as far as I'm concerned, the black caps are not really of interest to the cats. They're just leaving them alone. So that's a good thing. Now I feel somewhat safe leaving Jugglebot unattended for a couple of days, and I hope, and in the past, so far recently at least, the cats have left it all alone, which is a big relief. That was a very annoying problem to have. Cool. All right. The next thing is this. I'm going to try to kind of go in like chronological order of what I experienced over the last couple of weeks. And after I changed these caps over, the next thing that I encountered was that I would try to get the robot to move around, to go through its sequences, but for some reason, one of the legs just wasn't working. It would power on, it would start to go through its like boot up sequence, but then it would just not respond to anything else thereafter. And I was very confused by this. There were no errors being thrown, which was a big thing, and I'll elaborate on that in a sec. But yeah, there was no indication that anything was going wrong except for the fact that it just doesn't work, or didn't work. Turns out the problem was, this cable has slipped out, or did slip out. And I have literally no idea how this happened. This was only on one of the legs. And for reference, for anyone who hasn't seen these before, these little JST connectors, the way that these are put together is that on the end of each of these wires, so everything except for the yellow one right now, there's a little metal sleeve thing that you like crimp onto the end of the wire, and that is supposed to hold onto the wire really, really tight, and then that slots into this white plastic part, and that's what actually like allows for that connection to be made to other wires. Somehow, this single yellow wire became uncrimped and slipped out of its little metal tube thing. I don't know how, I don't know why, I don't know what event made this happen, and it was a massive pain in the ass to fix as well. So now this solution that I came up with was, rather than replacing this entire length of cable, which would take too long to make a whole section of cable again, I was thankfully able to just barely attach a new piece of wire onto this. So the yellow wire is now extended by like a centimeter longer than the other one, so it's kind of bending around a bit weirdly. But it's working for now, at least. Yeah, I was not expecting that to happen, and it was very annoying. And this led me onto this whole rabbit hole of trying to figure out, why did an error not get thrown here? And I can't remember the specific details here, because this was last year when I was doing this. But I've had to, I basically went through and like massively changed how I was doing all of my error handling. I was doing it very everything was kind of being handled on its own, but now I've kind of collected everything together, and now I can actually have a, previously, previously the way I was doing things is that I could only ever store one error at a time. Like I would just have one slot for what is the error here, and that would get shot off, and then like it would just be handled, and my hope was that if there is an error, then the system will just respond to that error appropriately, it will be handled, and then we can move on to the next errors. But that's not a very robust way of handling things, because if there's multiple errors and one of them doesn't really need much to be done about it, and another one does, then if the one that does need something to be handled is overwritten by the one that doesn't need anything to be handled, then nothing will be done, even though something should be done because there's an error. Such a stupid way of doing it. But now I have all of the errors in like basically every single spot where there can be errors. So this is on individual motors as well as for the robot as a whole. All of these errors can be lists of errors. So now I can have multiple errors and they can all be remembered until they are dealt with. After all of this work, this was like, I think 2 or 3 days of like going through and changing the way that I'm handling these errors. Even after all of this, I was like, okay, cool. Would this error, this one with this broken cable, would this have been detected? And I went through, and unfortunately this was after I'd already fixed this mechanical problem, so I couldn't actually test this specific problem as it was, but I could get kind of close, and the answer I think is no. Because the thing that makes the O drive fire an error for this cable being out is not something that I'm actually putting the robot through. So as I run the robot through its sequence, at no point does the O drive realize that this cable is not in, using the sequence that I'm putting the motors through. I can make the motors do a different thing, and then that will trigger the O drive to say, hey, something's wrong here, I'm not getting a signal that I should be getting, but that's not something that I need to do to get the robot to work, and so it's not something that I'm currently doing. So after all of that, this could happen again, and the only way I would know is by physically checking the robot, which is a little bit annoying. But yeah, I'm a little bit, part of me in the back of my mind is a bit like, oh crap, like if this was caused by a ball landing on the cable, then it's not impossible in the future that when the robot is moving around doing more complicated sequences, that the same sort of thing could happen where a ball hits the cable, that leg just like shuts off, and then I have no idea why. Hopefully nothing bad happens from that. We will see. Okay. Next thing. I don't like the way that this zooms. There we go. Cool. Okay, now this is probably my most exciting update for this week, is that Jugglebot can now catch from me if we have a bit of a lenient definition for what it means to catch. I'll show you what I mean. So here, let me show you this. This is I'm not going to do this live because, again, this was last year when I was doing this and I've changed some things around, but you can watch this recording. So I'm throwing the ball and we can see, so up in the top left, we've got the, like my space in here, this is like being tracked, and we can see that the ball, I'm just going to roll this through slowly just so we can see what's going on. You can see that ball enter into the frame and then it comes along, and so I'll now play it proper speed, throw the ball in, ball lands in, and I'm stoked. But yeah, you can see there's a couple weird things going on here. So for one thing, the hand is not moving at all. So, and that was intentional. I was not trying to make the hand move at all. My plan for this, my hope was that I could just get the system of, I throw the ball, the cameras around the room, like there's one up here, these track the ball and then figure out where it's going to land, and then we get the robot to move to that landing spot. I wasn't intending on getting the hand to actually do any catching or anything just yet. I just wanted to make sure that pipeline of tracking to getting the robot to move was working. And it is, which is awesome. There are like another little thing that's, I don't know, a bit, I wouldn't like go shouting from the rooftops about how excited I am about this, because it's still a bit like, it's a technicality of a catch in my opinion. Like you can see it bounces off that front carbon fiber tube here, that little boop, before it goes in the hand. So like if that tube wasn't there, then this ball would not have landed in the hand. But it still did at the end. Yeah, so there's definitely some things to be improved here. But it works. And yeah, I'm pretty surprised by that, to be honest. So yes, there were some strange things that happened before this could work. The first of which was to do with the differences between these two images here. So on the right, we have, this is the base of Jugglebot as it is seen by the cameras. So we've got these 6 tracking markers around on the base. The reason why there's some of them like half-half is because the tracking software expects, I've told it beforehand that I have these markers in this orientation with respect to each other, and this is where they should be. So one, I think the darker color is like where it's expecting them to be, and then the lighter color is where they actually are. So some of them are like ever so slightly off of where they're supposed to be, but it's close enough. Yeah, so on the right is where is the tracking data. On the left is Jugglebot as I have it in my CAD, and also how I have it in my in all of my code. And I encourage you to try to spot the difference between these. It is a fairly glaring difference once you realize it. Hello Xavier, good to see you. Yes, the difference is, of course, my coordinate systems are different. For whatever reason, the tracking software, which is called QTM, has Z being up, which is good, we like Z up, but then has X going forward and Y to the left. I didn't realize this, and I have Z up, because Z up is good, and then I have X to the right instead of forward. So everything that the tracking software sends to my code is going to be shifted by 90 degrees about the Z axis. And unfortunately, I can't seem to find any videos of this. I swear I was taking videos every single time I was getting the robot to move around, but I haven't been able to find footage of this. But the end result of this coordinate system change was that when I would throw the ball to Jugglebot, instead of moving to where it's supposed to go, it would move like on a very weird angle. Like it's kind of hard to describe, but it was basically just like, it was obviously moving in a kind of correct way, but just like in the wrong direction. It was very weird. It took a little bit longer than I was hoping than I'm proud to admit, to realize that this was the cause. But thankfully, this is actually very easy to fix. The way that I have fixed this right now is, and probably for the future, is to just basically take all of my data from the tracking cameras and just rotate it. That's it. I know that there are procedures in ROS to do all of this like coordinate transformation automatically, so that you can say this data is in this reference frame, this other data is in this reference frame, and we want both of these to be in a third reference frame, and it will just like automatically convert them for you. I know that that's a thing, but I haven't used it before, and I haven't really had enough of a push to make me learn how to use that yet. I am aware that I'm getting to the point where that's becoming more necessary, and I think that at some point I'll probably learn how to use that properly and like go back and fix all of these things up, but there's other things for me to worry about right now. So I'm leaving it. Yes, there is also a strange behavior with one of the legs. It's only happening with the same leg every single time, but I don't know if that's an issue with the leg or if it's something else. So let me show you our recordings again. And let's do this one. So same sort of thing. I throw the ball in. It goes to catch. This time, unfortunately, it misses by quite a lot for whatever reason. Also, for reference, I have not done like 1,000 throws and one of them happened to land. I only did like 5 or maybe like 10, and I think 2 of them landed. So it's not terrible odds. It's obviously not as good as I want it to be, but it's not terrible. But anyway, so the robot moves to try to catch the ball. It misses. It doesn't realize that it missed because it doesn't know. But then when it tries to return back to its like flat position, because I have it set up right now where, well, I had it set up so that when the ball comes in, it tries to catch. After like a second or something, then it will return back to its like flat position so that it's ready to try another catch. So now it's caught, it's trying to go back, but then for some reason, this leg just collapses. And the other one's returned back, but that one doesn't. Like, so if I play it back in real speed, I'm really not sure what's happening here. Like it starts to extend to go back, but then it's like, nope, I can't do it. That's it. I give up. And then after that, I shut it off and they all go back down. I'm really not sure what's happening there. That happened quite a few times, always with that exact same leg. But again, I'm not sure if it's a problem with just that leg or if it's a problem because the platform is tilted in such an aggressive orientation that my thinking is that maybe because there's so much weight on that leg when it's tilted back in the way that it is, that maybe it doesn't have enough oomph to kind of push out of that position. I'm certain that if that is the case, then that is a result of me setting some like torque limits a bit too low. I'm certain that these motors can push more than hard enough to lift up the entire platform by themselves. But I don't know what would be causing that. Yeah, I don't see any, as far as I'm aware, all of my torque limits, everything are like quite high. I don't know. And I don't, again, this was last year when I was doing this, but I don't recall there being any errors spat out from that motor either, which is weird. It just like gives up. Very strange. One thing that I want to try, one big thing that I want to try is to try throwing the ball from a different spot. Hi, Michael. So all of these tests that I ran were always from me standing kind of where I am now, throwing the ball out that way, and that led to the robot moving in the direction that you just saw. And that always had that same leg collapse. But I'm thinking that maybe if I try throwing from a different spot, so that way the platform moves in a different direction, I might be able to kind of infer whether this problem is orientation related or just that specific leg. Maybe, but we'll see. John says, how much current on that actuator when it happens? Is it stalled, saturated? I don't know. I was not logging those things. Bit of a spoiler for later on in today's stream, but I was not logging those things before. And yes, John says, it looks very unfavorable kinematically. Yeah, there's a lot of, it's really kind of pushing down on that one leg quite a lot. So yeah, we'll see. Definitely more experiments to be done. What was this one? Oh yeah, this. So I just want to show this one as well. This is a very near miss, showing that it's not like, it's very close to being correct. Look at that, look at how close that is. So close. Anyway, let's go back to the updates. Oh yes, okay, so another thing. The carbon fiber tubes are bisecting the held ball. This is an interesting problem actually. Before I get to that, Michael is asking what voltage am I using for these motors? They are running on, the whole system is running on 45 volts. Yep, so it should, these motors are strong. Like these are super, super, super strong. And like the strings that I've got in the legs, each one string can easily hold me. Like they should be super, super strong. But yeah, for some reason it's collapsing. Yeah, so this bisecting problem, this is an interesting one. So let's go to the one where it caught. Yes, we can see this here. Okay, so I would like to draw your attention. Unfortunately, I can't zoom when this is in full screen, but this should work. All right, so let's have a look at this. So this is the tracking of the ball. And we can see we start, there's no ball, it comes in, ball comes in, it lands in the hand, it is occluded for a second, but then, boop, all of a sudden, one ball becomes two. Let me zoom in a bit. Look at that. So we've got one ball coming in, and then all of a sudden, whoop, we have two balls. The reason for this is because when what these cameras are trying to do is they're trying to find circles, and that's why I have this. Well, it's one advantage of having Jugglebot juggling balls is that whatever orientation this is in, this is always going to be a circle. So I can very easily, well, somewhat easily, just cover this whole ball in this retroreflective tape, and this will be seen by all the cameras as a ball. The problem is that when this ball is, because these markers are so damn big, when this is blocked off halfway through, some of the cameras will see the top half as one circle and the bottom half as a different circle. And then if enough cameras agree that, yep, there's two things here, it will split it up into two balls, as we see in this recording. And this happens very consistently. Whenever the ball is in the hand, it's very common for, let's go to this view. It's very common for one of these three tubes to be blocking the ball a little bit. So like if it was like here, according to this camera's perspective, this would appear as two balls, which is kind of annoying. And this is something that I spoke with a couple of weeks ago. I had one of the like reps for Qualisys, which is the company that makes these tracking cameras. He came over to like my place, which was pretty cool. And one of the things that we talked about quite a lot was this problem of like how to get that ball to always stay as one ball. And he has been working on these systems for quite some time and is for everything else, he was like, oh, there's an easy solution for this. Just do this, just do this. For example, one thing that I actually meant to mention a couple of weeks ago, but forgot to, is that for the calibration process of the cameras, we need to cover up all of the other markers. That's one of the reasons why I have those black caps that I showed before. This has been a reason why this is the main reason why I haven't added any markers to Jugglebot's platform yet, is because I wasn't sure how to cover those up during the calibration process, because these little markers, these little caps that I've got would not stay on if they're not like sitting on a flat surface. And for so long, I was like, oh, if I put markers on the platform, how can I cover them up? Like, this is gonna be so annoying. Every time I calibrate, I'm gonna have to do something to cover up all these markers. I asked this guy who's been working on this for ages, and he's like, why don't you just get a piece of fabric and put it over the top? And I was like, you're a genius. Such an obvious solution. Anyway, so this guy obviously knows his stuff. And he had no idea for this. He's like, I don't know, there's not much you can do. Like, can you get rid of the carbon fiber tubes? And I was like, not really, because they're glued in, and I'm not interested in changing the hardware that this robot is using that much right now. I don't think that's gonna happen. And that's it. Like, there's not much we can do about it, which is a bit annoying. Thankfully, like, this could definitely be worse because it's only happening when the ball is in the hand, and usually when the hand is quite low in its stroke as well. So I should be able to just say, okay, do we expect the ball to be in the hand? Yes, then don't worry about tracking it. Like, maybe track it for the first little bit just to make sure that it is in fact in the hand, but after it enters the hand, we can just say, yeah, it's still in the hand. If we see two markers, don't worry about it. If we see one marker, don't worry about it. Just ignore it until we throw again, and then we'll continue the tracking of it. Maybe it would be nice if we could just have one consistent path of like each ball can just be tracked forever, but I don't think that's going to be very easy to do when this is getting split up like this. I don't know. Any suggestions? I am all ears. This is a strange problem. Okay, next thing. I think that this is when I was going through and doing all of the error correcting that I mentioned earlier. I also realized that the way that I was doing the boot sequence was very convoluted. I had a lot of complexity in there that I didn't need to have, and now this is massively simplified. There is one little caveat, which is that some things are running automatically, which in my opinion is fine, but overall this has made the whole sequence much simpler. So what we're doing now is when the system turns on, the CAN interface, which is the thing that interfaces between the robot and the CAN bus, will automatically poll the Teensy to say, hey, what was going on the last time we ran? Did we home? Did we do the encoder search? And were we in a moving state? If that is the case, then we can just move straight through onto, yep, we can move now. Previously, I had a whole complicated thing to do this polling for me in my state machine, but now this just automatically happens as soon as the system boots up. Then this information is bundled into our robot state topic, which I believe I showed 2 streams ago, which is essentially all of the, my goal for this topic is to have all of the information pertaining to the actual physical robot all in one topic. Nice and easy to access, and everything's clear. It's all there. Everything about the robot is there. Everything about the physical robot is there. So now that also includes what the state was last time the system ran. And then this gets sent off to the state machine, and the state machine can then read from this topic and say, hey, yep, cool, last time we ran, we got through the encoder search, but we didn't finish homing. And that means this time we need to finish the homing sequence so that we're then ready to go. This has completely gotten rid of the pre-op check state that I had before, which is not worth getting into. And there's also no more mini, what I called the mini state machine, which used to be in the boot state. The fact that I had like a little shitty state inside my main state was just confusing. And now it's much simpler. Everything is a lot more straightforward. Okay, yes. So next thing, but like related to what John just asked about is when he asked how much current is on that motor, the collapsing one. I couldn't answer that question. I have no idea, literally zero clue how much current was on that motor. And there have been quite a few times while I've been using the robot where I've been asking myself, what just happened? What the heck just happened? Everything was too fast, too many things going on at once. I cannot see what's going on. And also there's a lot of things that I just cannot know myself because I'm not in the system. But now, thanks to some help from Jev and James, I have finally set up my ROS network to bag each session. Bagging is the term that ROS uses. I don't know why. I don't know if I really vibe that. Oh, this is another thing. I'll talk about that in a sec. So many things. Anyway, so let me make this bigger so the quality's better. So now I'll talk about this specific data in a sec, but now I have PlotJuggler set up. So I can basically set up the ROS network to automatically record as many topics as I want to. I can record all of them. I think if I do all of them, the files might be quite large. I'd be very interested to hear some opinions on this. But right now, I'm just recording the robot state and the hand trajectory, which I'll also talk about in a bit. So let's get rid of that one. No distractions. What? Yeah. So let's focus on the robot state now. So I can go through robot state, and with PlotJuggler, so this is like a recording that I took yesterday, I can basically come through and I can say, what was my, let me add a new plot so I don't get confused with anything. What was my, what did John ask about? Current on that actuator. I believe that's bus current. So I can see here, oh, that was my current, oops, on the actuator. And I can zoom in here, I can scroll around, so I can like pan my head through and I can see what all the values are. The values also update over here, so I can see what I can expand as many of these as I like to see what all the different motors are doing, and I can compare, like if I want to see the current of this motor compared to the current of a different motor, we can see, the hand current was way higher than the leg current here because the hand was actually doing something, the leg was just off. So yeah, this, I hadn't set this up until now because I was aware that there was a way to replay ROS sessions like this, but I never really had that strong of a need to do it. I was always like, yeah, something weird just happened, but also I can just run the same thing like 10 different times and then see that error again and again and again, because all of the errors that I was facing were like very simple, repeatable errors mostly. And I could just go through and repeat the error again and again until I could figure out what the problem was. That is not a very stable, yeah, no, I think you're right, John. Yeah, that is not a very stable way to move forward with this system because I'm now encountering errors that are not at all repeatable and will only happen every now and then. And there's just so many things interacting with each other that it's very hard to figure out what might have gone wrong without having a good recording of this. So now, yeah, all of the information about what the physical robot is doing is always being recorded. I would like to also record things like when the balls are being tracked, and then I can also record the different positions of the markers on the robot once I add markers to the platform in the hand. And hopefully, once this is all working, hopefully this isn't too much data that the files become like gigabytes and it's just too cumbersome. Fingers crossed. I don't think that should happen, but yeah, it'll be so good if we can just run a session, do everything we want to do, and then have a full replay of everything that happened. We can get tracking data of everything that happened. We can get data of what the actual robot was doing, every single message that was sent across the CAN bus, maybe. That might be a bit of a stretch, but we can get at least a lot of information and then replay and try to figure out what's gone wrong. And this PlotJuggler, where are we? This one? This PlotJuggler UI and program is really slick. I'm very new to it. I only started mucking around with this yesterday, but it looks very, very good so far. It's really easy to make different plots and to add different things, and like you can see they all move together. You can do cool things like you can plot one data point with respect to another data point. Like, I don't think this will make much sense, but I actually haven't tried this yet, but we can see what happens. If we want to plot, I don't know, vel estimate against, I don't like that this is in alphabetical order. I'm so used to it being in a particular order. So yeah, we can plot, this is the velocity versus the position. And we can see that as we pan around, this moves along its own, like, yeah, it moves in the way that you would expect it to move, basically. It's very cool. It's very, very fun. There's a lot to do with this, and it's really good. I also just want to mention that I tried using the Foxglove system, the suite that is kind of similar to PlotJuggler, where like it's designed to just allow you to replay data and observe what happened and like analyze it. But unfortunately, for whatever reason, Foxglove did not work for my for my robot state topic. So this topic, it's filled with this array called motor states. So in robot state, we've got a couple like robot-wide things, like has the encoder search been complete? Has it been homed? What are the pose offsets? Blah, blah, blah. But then we also have 7 sets of the states for the specific motors. And for whatever reason, Foxglove doesn't like this. It tried to plot all 7 at the same time, and so the data was just like crazy wacky. Like I couldn't expand it out like I've been able to here in PlotJuggler. So PlotJuggler is very good. I would definitely recommend. And you can also use this to plot the data in real time as well, which I haven't tried yet, but I like the idea of a lot. And I'm very hopeful that I might be able to just, for part of my big Jugglebot GUI, I might be able to put PlotJuggler into part of it, which would be so nice, being able to just observe everything whenever I want. It's really good. Yeah, John said, I think you're looking for motor current for the motor IQ phase current. And yeah. So I grabbed the wrong thing before. Yep. Okay. Yes, so now actually just to wrap up with this one, what this means is that because this is being tracked every single time I run the Jugglebot system, if ever anything goes wrong, I can say, what went wrong there? And then I can open up PlotJuggler, add my data in, and then just replay it back and go through as slowly as I want to with whatever data I want to, and just play it through and just see what happened in the lead up to that event, which is so obviously helpful that I don't know. I'd be curious to talk with me from like a year ago or like 6 months ago and be like, hey, why don't you set this up? Because I definitely was aware that this was a thing, but I just didn't really have much interest in setting it up. But now I'm like, this is so obviously helpful. I don't know. Yeah, I do some funny things sometimes, as I'm sure you're probably all aware by now. All right. Yes. So actually, one last thing on this is that this will mean that when I eventually get back to testing Jugglebot catching the ball that I throw to it, if we do find that this leg collapses again, then we can play this back and say, maybe, as John suspects, or as John has suggested, perhaps the current is too high, or perhaps something else has gone wrong that we aren't able, that's not very like intuitive or obvious, and we can just see what it was. It'd be very helpful. Okay, next thing. I need a drink of water. I'm finally updating the hand control, which is something that's a little bit overdue, but there was never, it was not a huge issue, but it's good to finally fix it up. So before, we were using 3 messages to command the hand. And these were input position, so where should the hand be? Vel, like velocity feed forward, which is how fast do we expect the hand to be moving at this point. And then also torque feed forward, which is how much force do we, or how much torque are we expecting the motor to need to output at this time. Because we, as the humans who are kind of observing this whole situation, we know that at the start there's a ball in the hand, and this is adding inertia to the whole system so that when it goes to throw, it needs to push the inertia of the ball as well. But then once the ball has already been thrown, that inertia disappears, and suddenly we have much less force that's necessary. The O drive doesn't know anything about what's going on here, but we do. And we can model this system beforehand and tell the O drive exactly what we expect the velocity and the force that is necessary to get the system to behave the way that we want. And in theory, this should mean that we can get the system to behave much closer to what we want than if we just let the O drive blindly try to figure it out, which it wouldn't be able to do. Yes, so before we're using 3 messages, and this was only necessary because O drive had a fixed scale on the feed forward terms. So on the velocity feed forward and on the torque feed forward, their unit was 0.001 revolutions per second or Newton meters. And because these values are int 16s, this meant that the maximum velocity feed forward that you could tell the system was around 30 revolutions per second. So that means that if you ever want to, in the past, if you ever wanted to command your motor to go to a certain position with a very high velocity, faster than like 30 revolutions per second, you just couldn't. It just wasn't possible. Unless you sent one message for each of these data types. Yes, for reference, because I didn't really make this clear, this is one single message. So you should be able to send all 3 of these pieces of information with one message. It should be possible. It's there. O drive has made it possible. But because in the past they had this weird ass, not weird ass, but a fixed unit, we were not able to use this because we needed a faster velocity. For reference, we're going up to like, the tests that I've been doing are like 150 revolutions per second as the velocity feed forward. And if we're doing high throws, it'll be much higher than that. But now, this is not necessary to send 3 messages. Now we should be able to just send one single message, this set input pos message, because thankfully, O drive has made these scales changeable. So we can go in and we can say, I don't need 0.001 resolution, I only need 0.01. And this means that we can go up to like 300 revolutions per second, which should be enough for now, at least. Yeah, so this should all be easy in theory. I should be able to just go into my code and say, yep, cool, okay, we can get rid of all of the sending individual messages, and now we can just group it all together and just send one, because we have changed this scale. For changing this scale, I believe, I don't know if this is necessary, but I don't know. This is where my understanding kind of wavers a bit. And the fact that I'm talking about this the way that I am may lead you to think that this is not working the way that it should, which is correct. So one thing that's kind of weird is that I had to change the scale factor in the database file. So this DBC file is what O drive uses. It's basically how we convert. We say, hey, I have this command. I want to set the input position. And to do that, I want to set the input position, the velocity feed forward, and the torque feed forward. I can do this in my code using fairly human-friendly terms. I can just like write in vel ff equal or like colon this value, and so on. That's in like very human-friendly terms. But then to get that into a language that the O drive understands, there's this DBC file, which basically converts between human-friendly stuff and O drive hex nonsense. And in that DBC file, there is this factor in here. And I only discovered this after a bit of stuffing around, but as far as I can tell, this factor will automatically apply to whatever value we set for this variable. So whatever we set the velocity feed forward to be, this will automatically multiply or divide by this factor to put it into what the O drive is expecting. And because I have told the O drive hey, I'm no longer using 0.01. Sorry, I'm no longer using 0.001. Now I'm using just 0.01. I'm pretty sure I need to change this. I have changed it, but it doesn't seem to be working properly. But I'll get more into that in a sec. John is saying, pretty awesome that they're this open to improving the code. That was a fast turn. Try doing that with a big motor controller company. Yes. Yeah, no, that is true. They were pretty fast with it, actually. And as far as I can tell, we are the only people who have raised this as a concern so far. So yeah, you're right. Like that was pretty good of them. It feels kind of weird that they did it the way that they did in the first place, but I guess maybe people didn't have this issue before. Yeah, I don't know. He also says you can set that command using the ODrive tool as well. Yes, I have changed it on the ODrive. Like on the ODrive itself, I've set that value, but that doesn't change the DBC file, and I'm not really sure how the DBC affects the data that's coming through. I need to do more investigation into this. And yes, this feels very sketchy. So part of the sketchiness of this is that this screenshot that I've taken here is from, I've got a program on my Windows PC, I can't remember what it's called, but it's basically, it's like designed to analyze these DBC files and like kind of interrogate them. And in this software, this is not a writable field. I cannot change this value. This is like fixed, it's stuck. And I was like, that's a bit weird. That probably means that I shouldn't be changing this. But I was able to just open the DBC file in like a text editor and change it that way. But it feels super sketchy. I need to do a bit more testing of like what CAN messages are actually being sent across so that I know what this is actually doing to my message. Because if I print the data that I have after converting from like human-friendly terms into ODrive-friendly terms, I don't understand it. And I need to expand it back out again so that I see what's actually happened. It's a whole thing. And yes, strange things are happening indeed. So this is where we get back to our data here. Let me, there we go. Okay, so this data is from, let's get rid of this one because we don't need that. So this is from, I'm trying to get the hand to just throw the ball and then stay at the top. I have completely removed all of the code that was getting the hand to go up, wait, and then go back down again. Right now it's just going up and then staying at the top. The reason for that will become clear in a sec, or in a couple of minutes, but that's what I've done. So this is only trying to throw. So let's zoom into here. We can see the red line. I don't know if you guys can see, I don't know if it's very easy to zoom here. I'll try to figure that out for next time. But yeah, on the top, we've got positions, then we've got velocities, and then we've got the currents. At the top, in the positions, the red line is the position estimate, so like where the motor actually is. And then the blue line is the input position. So this is the position that I'm commanding the motor to be at. Now, something that's worth pointing out here is that the input position and the velocity feed forward and the torque feed forward, those are all coming from one ROS node, then getting sent over to the one that actually commands the robot to move around, and then it gets sent over CAN to the actual robot. So I believe that's why this blue line is a little bit ahead of the red line, is because this blue line is the one that's getting sent out from the first node, and then has a bit of processing to go through the control node and then out to the robot. And then only once it's gone through like control node, robot, and then the robot's actually started to move, that's when the red line starts to actually increase, because then the motor has actually started to respond. So yeah, that is a bit of a lag. I believe my x-axis here is time. I need to spend a bit more time in PlotJuggler to get a bit more familiar with setting it up so that it like maps against the actual ROS time. Because there is this timestamp that I've got, but it's in nanoseconds and seconds, which is a bit annoying. And I don't know if I can just like put that straight into PlotJuggler so that it figures out that the x-axis is like seconds plus nanoseconds. I don't know. But anyway, if this is in fact time, which I believe it is, then the difference is only like, that's 4.73 seconds up to like 4.77, so it's like 0.04 seconds, which is not long, but I don't know, yeah. So anyway, I'm not too worried about the fact that this line is, that they're not synced up perfectly temporally, but what is more concerning is the fact that the position, it doesn't even end up where it's supposed to end up. Like here, it's the last position that I'm commanding to the hand is to go to 6.5 revolutions. This is not the full stroke of the hand. This is only like halfway because I kept having it run into the end, and so I moved it back down a bit. So it's only supposed to go to 6.5, but at the end, it's up at like 7.8 almost. It's like, why is it going so much higher here? Why doesn't it stop here where it's supposed to? It's very bizarre. And like the velocities, so like on this second one, the light blue line is the velocity estimate, so what the mode is actually doing, and then the purple line is the commanded, like what I'm expecting the velocity to need to be. Again, we can see that there's a time shift, but I think that's okay. But the same sort of thing, the velocity doesn't get anywhere near to what it's supposed to get to, and the hand is still overshooting. So I don't know, there's some weird stuff happening here. I'm not really sure what the problem is, but at least I can go back and run things through and check them over again. One main thing that actually, no, I'll talk about that. Let me save that thought just for a second. Yeah, so John is saying, ooh, yeah, I feel like you may be changing an internal variable you shouldn't be. Okay, so let me show you what I'm changing then. So let's pull up, this is the ODrive GUI, which is what I've been using to do a lot of these controls. This is what I'm changing. Input vel scale, and let me make this bigger. Get rid of this. Here, the axis 0 config can, input vel scale and input torque scale. These used to be 1000 because their scale used to be 0.001. I've now changed that to 100. I think that's correct. What did you say? Can config input fix? Yeah, yeah. So I'm pretty sure that's right, but I don't know about the DBC file. Are you, okay, so John says, I'm using 100 as well, and that works for me. Are you using the DBC file for like converting to like construct your CAN message, or are you packaging that some other way? Why do I need to change the DBC file? So the reason why I changed that in the first place is because I was realizing that I was having an issue where I was trying to send a value of, I don't know, let's say like 100, but I was getting an error saying that we're not able to send that message because it doesn't fit in, it's too large of a value because it was like bigger than an int16. And after a lot of mucking around with like printing at different stages, I realized that before I was doing like everywhere up until we got to the DBC encoding, my value was 100. But then as soon as we did the DBC encoding, that value became 100,000. So the value that was actually trying to be sent was 100,000, not 100. Even though everywhere up until the DBC stage, it was 100, 100, 100, 100, 100, DBC stage becomes 100,000. And so then I was like, what the heck is going on here? Like, why is the DBC file thing affecting anything? And that's when I went into it and then found this like factor term. Yeah, I have a simple CAN interface that constructs a message. Yes, you need to pack the integer with a different scaling, and the scales need to agree. Yeah, so I would have thought that changing the DBC, let me go back to you. I would have thought that changing the DBC to the like equivalent would fix things, but I don't know. Yeah, I need to get my CAN logger out and like see what values are actually getting sent across the bus and compare those against what I'm expecting. Yeah, I've got a bit more processing to do to figure out what's going on here. But I guess it's comforting to know that it's working for you. That's good. That means it's just a me problem, not anything else. One thing that I only realized 40 minutes before starting the stream, so I haven't had any time to investigate at all, and that may be the cause or a contributing factor to why we're getting some weird happenings in here, is that when I am done controlling the hand to do this stuff that I'm showing now, once that's done, and I've done a couple tests of the hand moving around, if I connect to the hand, I can see that it's in velocity control mode, which it shouldn't be. It should be in position control mode. So I think that it's possible that there's some weirdness going on and I'm actually not even controlling the position at all, which would kind of explain why the position is overshooting by so much, because it's not even looking at that command at all. It's just saying, I don't care, it doesn't matter for me. Although the velocity still doesn't agree with what it's supposed to be, but I don't know. I suspect that this is not helping the problem. So yeah, a little bit more investigation is necessary though. Always weird things going on. Okay, now this is a big topic, I think. This is an important thing. So I've thought a lot about what is necessary for juggling and whether throwing or catching is more important. And at the end of the day, I think both are obviously super important. If you can throw but you can't catch, you're not going to be able to do much. You're going to get you're going to get a flash done, but nothing else. And if you can catch but you can't throw, it doesn't matter how well you can catch. If you throw and the ball ends up all the way over there, like your reach is only so long. So they're obviously both very important. But I have, I don't know, returned back to the thought that these two systems are these processes are very different from one another. Throwing needs to be extremely precise, like precision is absolutely key, but catching, you don't need to be as precise, I think. As long as the system is like robust and is a little bit tolerant of any errors, I don't think that the catch needs to be nearly as precise as the throw does. So there's two things have led me to, there's two things in particular that I've been thinking about a lot that's kind of led to what I'm about to share. The first is the conversation that I had with Kai probably a couple of months ago at this point, who, for reference, he's a guy in Germany doing his PhD on making a robot juggle, like an industrial arm robot, and it's a super, super cool project. And he commented that he doesn't use velocity matching at all when catching. And what I mean by this, what I mean by velocity matching, is what John and I have been trying to do for quite a while is to get the hand to come down and like anticipate the ball coming in and then like match the velocity of the ball, so that when, like, as the hand lands in, the ball will just like softly, gently land in the hand, and it'll be like in orbit, having one spacecraft meet up with another spacecraft. Like, that's not going to work if they're flying past each other, but if they match their speed so they're going the exact same speed, then it's as though they're completely stationary with respect to each other. That's what we're trying to do. Kai mentioned that he doesn't do that at all. He makes zero attempt to velocity match. And in fact, when he got his robot to do two balls in one hand, the way that he did that was just to have 4 set points of saying, you throw here, you catch here, and then you go down to these 2 points to like complete the catch or the throw. So the hand was just going through this like figure 8 sort of pattern. It was just moving between these 4 points as smoothly as it could. And that meant that the ball was just like often just like landing in the hand when the hand was often moving down, but it was not trying to like match the speed of the ball or anything like that. So that's one thing, is that he has had success with this and has not attempted to do any velocity matching. A second thing that has led me down this path that I'm about to share is I made this hand testing rig, which I'll put the link to this CAD in the description once I finish the stream. I forgot to before. So this is a testing rig. It's on the wall behind me, but you probably can't see it from here. And my intention with this is just to get a better feel for how the hand behaves, essentially. And originally, I had this set up. Let's ignore all of this. Bit of a spoiler. I had this set up with a spring, so that there was a string that ran up from the top of the hand, up over these pulleys, down through this little locking mechanism so that I can pinch the string off if I wanted to, and then down, the spring would attach right down on the bottom. And this was pretty fun to play around with, to be honest. It was a lot more fun than I was expecting it to be. You can just like throw the ball as hard as you want into it and it will just nicely absorb the energy of the ball. And yeah, that's playing around with that. I don't know, made me realize how good it would be if I could just have Jugglebot throw the ball, and then when it wants to catch, if it could just move there, have the hand at the top, and just be ready for a catch. It's in a state where it is compliant enough that when the ball comes in, it will just move with the ball. It obviously won't be perfect because there's some inertia involved here, but the motors that we're using are like the tiniest little things ever, and overall the inertia is fairly low, even compared to these balls, which are honestly quite light. Like this ball is like 71 grams, I'm pretty sure, which is a bit annoying. I wish it was a bit heavier, but it still does have enough energy to move the hand. Like let me show you this shot. We can zoom out a bit. By the way, if you're wondering why I'm using this camera instead of my normal camera for like Jugglebot views, it's because my normal camera is cooked. Look at this. What is going on here? I can still move it around and like you can see me. Hello. But it's just fucking wrecked and I don't know why. Very annoying. But anyway. So if I have the hand up and it's just like everything is off right now, if I just drop the ball in, it still does move with the ball. It's obviously not perfect, but especially if I drop it in like perfectly bang on, it actually does a fairly good job of moving with the ball. And I think that if the hand was moving down at the same time, then it would be more than compliant enough to keep the ball, more than like able enough to keep the ball in the hand and move with it. So let me address some comments before we keep going. Biohazard says, hi, I run a small channel about making working Lego guns. Your designer pulley actuator has saved me time in designing for a machine gun mechanism. That is very cool, Biohazard Madness. Very nice. If you do, once you finish this off, I would love to see the results of this. I don't know how you can share stuff on YouTube, but if you just comment on any of my videos that you've like done it, I would love to see that. It'd be very cool. It's very nice to see when people actually use things that I've made. It's very cool. I like it. Stormy, how you're going? Good? Hope you're going well. Yes. So, I want to make the hand as compliant as possible. There's one more thought before I go into what I've done so far on this. One more thing that is a problem with the velocity matching that John and I were trying to do up until now. And it's for me, this is probably the biggest problem with the velocity matching approach, is that the timing has to be so spot on. If the ball is coming in from a 2 meter throw height, I'm trying to remember these numbers correctly, the order of magnitude will be correct here. If the ball is coming in from a 2 meter throw height, it will be moving fast enough that to go from the top of the hand to the bottom of the hand would take 40 milliseconds, I believe, something like that, like tens of milliseconds, like not much time at all. So that means that if we're trying to velocity match, we need to be pretty damn spot on, because if we're a little bit too early, the ball is just going to land in the hand and it's just going to bounce around and the hand's going to be held there very stiffly because it's not designed to be compliant. So it's just going to sit there and the ball will hopefully stay in, but maybe not. But then also if we're like 50 milliseconds too late, which doesn't feel like a huge amount of time, then the hand is going to be right down the bottom and it's going to be the same problem. So like, we need to be like spot on with the timing for velocity matching to work, at least with a hand that can move as far as this one can. So yeah, in my opinion, that's a pretty big problem. Thank you, Biohazard. That's very, very kind of you. That's my first proper money that people have sent me, which is on YouTube. Very cool. Let me give you a heart. Very nice. Okay. Stormy says, I know you've talked about avoiding sensors in the hand due to managing wires and such, but this feels like an excellent use of a LiDAR sensor, which can be very small and very lightweight. Okay. One thought on that before I go into what I've done. So I have no experience with LiDAR sensors. Also on your comment of I'm hesitant to put cables onto the hand because of tangling and everything, that is true. But if the outcome is worth the effort, then I will still do it. I just haven't found anything so far where it is actually worth the effort. Because getting cables to go to that thing that's moving pretty quickly is potentially going to be some amount of effort. So with the LiDAR specifically, the immediate problem with this sort of, like, I've considered like laser tracking and like ultrasound tracking before, but the main problem that I've seen with that sort of, that I've thought of with that sort of thing, is that the ball, that would work awesome if I was throwing straight up. Like if the hand was always vertical and it was just throwing straight up, then we could track the ball the whole way up and then see it as it comes back down again. That would be fine, but that's not how most of the throwing is going to happen. Most of the time, the ball is going to be at some weird angle, and only, honestly, like in the limit, only right at the last like split second is the hand going to be collinear with the ball, so that it's like lined up with where the ball is coming from. So this means that if we have like, I don't know, if the hand is like, how can I do this? If the hand is here, and there's this like line of like LiDAR sensing coming out of it, this is only going to be lined up with the ball just at the last instant. And so like the hand might be here, but the ball might be over here, which means that the LiDAR is not even going to see it until right at the end. Yeah. Yeah, John says the vision system is already a big hammer for feedback of the ball. Yep, I agree. Yeah, so Stormy says, I figured LiDAR would work because it's usually not a super narrow beam. Oh yeah. And the balls are already retroreflective, which is true, so the hand would have a cone of vision, so to speak. That is an interesting idea, but I think John's right. I think that these cameras that I've got tracking these balls, I can track in 300 frames per second with 0.1 millimeter accuracy. I don't think I'm going to beat that with any other tracking system, to be honest. Yeah, I think that there is obviously latency problems, like getting the data from these cameras all the way through one PC, all the way through the network to another PC, and then out to the robot. There's a bit of latency in there. And the LiDAR could potentially be like a nerve reflex that we have, where like you hit your knee and your knee goes funky, where like that data can just like kind of be more internal straight on the robot. Like honestly, really, if we could get a sensor that connects to the teensy that's on the hand, we can get data, we can get like sensor data straight to that hand motor basically immediately. There'll be way, way less latency. But I'm not sure if it's worth it. Biohazard says, what if you used a soft silicon rubber robot hand / grabber? Yes, I thought about similar things, but I worry that that would make things more bouncy, that sort of thing. I've also considered adding, like, here I've got like a little piece of fabric that I was planning on like lining the hand with, so that it would be like that sort of thing, so that the fabric would add a bit of like a damping to it. Those sorts of things could work, and I'm very open to exploring them. I haven't really tried very many options so far, so if you've got any like specific ways to implement this, I would love to try them. But yeah, I'm more inclined to get it done with the O-Drive. I feel like the O-Drive should be able to do it. We're doing what I'll explain in a sec. I feel like a touch pressure sensor timer circuit might be suitable. Yeah, he says, I keep forgetting there's already, yeah. No problem at all, Stormy. Yeah, so Biohazard, I feel like a touch pressure sensor, yeah, we've considered pressure sensors, but I don't know. I don't think that's worth running the cables to the hand for. I feel like that's going to be not worth, yeah, because if we can just track the ball, like these cameras can just see the ball and they can see that, yeah, it's in the hand, and like we do have this weird splitting problem into two, but maybe we can just, like while the hand is at the top of its stroke, we can say, okay, the ball's in the hand at the top, now we just say that it's in there, and now we know that it's there, and then as soon as it throws, we can say, yep, cool, it's left the hand, Eagle has taken off, or whatever. I don't know airplane terms. John says, I definitely agree that it would be great long term to not have to use a vision system. I agree. Camera sensors on the robot frame would be nice to scale and make it more portable. I agree. That can wait until after it works great with a nice vision system. Thumbs up. I agree. Yeah, I don't want to get too distracted. Okay, so what have I done to make the hand comply? My first thought for this, because I had that spring set up in my like test rig thing, I thought, a spring is pretty good, but I don't want it to just be a spring. I want it to also mediate that response and kind of like slow down towards the end. And so I'm like, okay, maybe I can use a spring damper system like what I learned about in university. And this made me realize how much I've forgotten in the last couple of years since uni. And I had to go back, and thankfully I still have my Merriam Craig Dynamics, only the 6th edition though, so not the latest, but I had to go through and I did a sample problem. I did this 8/41, this guy. It was pretty good to remind me of how to actually do these things again. Annoyingly, I don't have any worked solutions for this textbook, so I could only compare my final answer, but thankfully after a bit of mucking around I was able to figure out how this stuff works again. And through this process, by modeling this as a spring damper system, I'm not going to, actually, I'll show my working out, but only only on here. I'm not going to like type it up or anything. So if anyone's curious, there you go, you can pause and you can see what I've done. But yeah, using that, the end result is that we have this equation for the position of the hand with respect to the velocity that the ball is coming in with, and also with respect to time, of course, because time is a relevant thing, or is a relevant thing, and omega n, which is the natural frequency. And this is also assuming that this is critically damped. Also, if anyone's curious, the natural frequency, it's been too long since I've done this, is the square root of k on m. K is the stiffness, m is the mass. Doesn't really matter too much, to be honest. And yes, we can see a nice, beautiful plot. I've put this into Python and had ChatGPT help me with with making a plot for this. Let me get rid of me. Actually, no, I can stay. Yeah, so what is going on here is we can change things like how high are we throwing the ball before it lands in the hand, how heavy is the ball, and also how quickly do we want the ball to stop. On the x-axis of this plot, we've got time, and on the y-axis, we've got displacement. And this is a bit of a weird, this is not a normal way to do this, I think, but what I've configured this so that I can basically set how long I want it to take for the ball to stop. And of course, I don't want the hand to actually follow this profile, but I'll talk about that in a sec. Oh, actually no. Yeah, but what I do want is I want the hand to start at the top. Once the ball comes in, it should follow this profile and gradually slow down and then stop at this bottom point. My intention is that I would then have some part of my code that will say, okay, cool, we have reached the stopping point, rather than continuing back up as though a normal spring damper system would. Instead, we're going to change our target positions and change all of our gains and everything and make us stop at the bottom. So really, we have a, like 35 centimeter stopping distance, so it'd be about here. And yeah, so the goal is that this would come down nice and smooth, and then stop at the bottom. But yeah, this plot, it looks so good. I love changing all these things around, and it's so nice to be able to see what effect these things have on like how the system responds. And an interesting one is that the ball mass doesn't change anything. It doesn't change the response of the system because I have set the system to always stop at the bottom, like to always have an inflection point, no, that's not the right word, a turnaround point at this stop distance. So the ball mass doesn't actually matter for the response of the system, but it does change the equivalent stiffness and the equivalent damping. So like how strong do we want our spring to be? If the ball is like 10 kilos, then we want a very strong spring, but if the ball is like 100 grams, we want a comparatively weak spring. But it will still have the same response because I've kind of forced it to. Yes, so this plot looks beautiful. I love it. It's very nice. But unfortunately, I can't figure out how to translate this into the O-drive gains. So what this plot gives us is, in here we've got a calculation for the equivalent stiffness. So if we reset the ball, let's just reset everything. So let's go to like a 1 meter throw height here. So if we want the hand to receive a ball from a meter high, we should set our system so that we have a stiffness of 4.7 newtons per meter. and a damping of 1.16 Newton seconds per meter. But I don't know how to convert that into the O-drive gains. On that plot, if you were looking closely, you could see that I do have a pos gain and vel gain term in there, but that's very, very not correct. That was using a ChatGPT suggestion, and I could immediately see that the units were wrong, and yeah, no, that's not right. But I don't know how to get them. So we've got stiffness in Newton meters and damping in Newton seconds per meter, but what we want is the position gain, which these are all, like, all of the O-drive units are revolutions per second per revolution, which is a bit weird. The velocity gain is Newton meters per revolution per second, and the integrator gain is Newton meters per revolution. And I am not sure how to go from these into these. It obviously, in my mind, has to do with the motor characteristics. So like we've got a 1500 kV motor, and there's all other like various motor constants that we can figure out for this motor. But even with those constants, I don't know how to convert between these two. What I would love is if there was some way to do this in theory so that we can say in advance, okay, we can see the ball is coming in, it has a peak of 1 meter above where we're going to catch it from, therefore it's going to have this much energy, and so then we should have this position gain, this velocity gain, and this integrator gain. So then as the ball is coming in, we can set those gains in advance so that the hand is just sitting there right at the top, ready to comply as it needs to for this given throw height. And then it will come in, nicely absorb the ball, and everything will be wonderful. Hopefully. And then if it's a really low throw, we will need comparatively less stiff gains, and so that it will still have the same outcome movement, but yeah, but the ball came in from a less height. So yes, this also doesn't currently consider the hand inertia, which is a bit of an oversight, and yeah, I need to go back and figure out how to actually add this in, because I am not 100% sure how to include this in my model that I made. I think I can just add them, like increase the mass, so like that, like K on M. I think I should just be able to increase M with the mass of the, like the equivalent mass of the hand and everything, but I'm not 100% sure. But in any event, I'm not controlling for that right now. Okay, so my thinking, after I got this plot set up and I was like, ooh, this plot looks nice. This is what I want to have happen. Like we're on the, progress is in the correct direction. But then after I got these massive gains, and I saw these, like, this was suggesting gains of like 860 and then the velocity gain of like 210. Just for, out of curiosity's sake, I did change those to be the gains on the O drive. For reference, my normal gains are like, position gain is like 18 and the velocity gain is like 0.001. So the suggested gains from the ChatGPT thing was like 2 orders of magnitude higher than what they normally are. And I'm like, oh, maybe it will work. It did not work. The whole thing just like vibrated like crazy and it was not happy. So then I'm like, okay, cool. Like this is not working. Can we just vibe it? Like, can I just play around and change my gains and just see how the system responds and then figure out a set of gains that will work? And my thinking here is that, like, okay, even if we can't figure out in theory exactly what the gains should all be, maybe we can just do a bunch of tests. We can drop a ball from 10 centimeters above the hand, figure out what gains are appropriate, drop a ball from a meter above and figure out what gains are appropriate. And then just kind of like interpolate between those for the different ball heights. That should work. Just have like a big lookup table, kind of. So I'm like, okay, cool. Maybe I'll just try changing these values around and see what happens. And my expectation, actually, let me show you one thing first. So here we have, this is the control loop that the O drive uses. So we've got position command, this goes into the controller, then we've got the velocity command, and so on and so on. You can pause if you want to. And they've got a description here of what all of these different things do. So like the position error is the difference between where we actually are and where we expect to be. And then when we're commanding the velocity, we take that position error and multiply it by our gain, So we say, okay, we are this far away from where we're supposed to be. Let's multiply that by whatever gain we've set to then bump us up to where we actually should be. And yeah, I'll put a link for this in the description and you can read through it if you are interested. But the end result is that I would expect that if we only have the position gain and the other ones are 0, then it should behave like a spring. So we're only considering the position. Like if I tell it to go here and I bump it and move it away, it should say, whoa, whoa, my position is not what it's supposed to be. I'm going to move back. If we have the position gain and the velocity gain, and only those two, then I believe it should behave like a spring damper system, where if we bump it really fast, it will say, whoa, this velocity is not what it's supposed to be. I'm going to make efforts to fight against that velocity change. And so it's going to be like a kind of like a non-Newtonian fluid where like if you push really hard and fast, it will push back hard and fast. But if you push slowly, it will also push slowly until your position goes really far, and then the spring part of it will try to pull you back. But this isn't what's happening. In reality, the behavior is very, very inconsistent. So I want to show you what I mean by this, because I'm very confused by what's happening here. So we've got, you can see Jugglebot, you can see me. Let's also add in, where is it? I think it's this one. Sorry, I had a lot of setup before this stream, annoyingly. And didn't get this set up, evidently. I want this one. Okay, cool. And, oh, why is there a filter on it? There we go. Okay, so let's make it so that we can see like this, and then we'll put me on top. Nope. Actually, no, we don't need me. Let's just get rid of me. Okay, wrong one. That one. Okay, cool. So you can see Jugglebot, and you can see the ODrive page. And let me zoom out a bit. So, yeah. What I'm doing when I'm playing around with this is I can manually change the position gain and, does that work? Yeah, there we go. I can manually change the position gain, the velocity gain, and the vel integrator gain, and then we can observe what happens as a result. And yeah, we'll keep the plots there as well. Okay, so we can turn things on. I can put the hand into closed loop control. We are in pass-through position control mode. Let's set the input position. So I need to change this back to what they were. And I believe this one is 0.008, I'm pretty sure. Nope, it wasn't, but whatever, let's just keep that one 0. So if we have, this is a velocity gain of what I normally use, I'm pretty sure, and a position gain of 18. So now, if I, see, look, it's so weird. It's so strange. Let me unplug it, and we'll start it again so it's got its like fresh normal values. It's a bit annoying though that when I unplug this, I have to unplug like 3 different things that actually loses power properly. Okay. That's in, and we're back on. All right, so now we can go closed loop control. Again, we're in velocity control for some reason, but let's go back into position. Cool, yeah. So I can, so I can move this around, and it's quite responsive, as you can see. Like, I can even get it to do little throws. I only just added this slider in today, and it is very fun to play with. But anyway, you can see that it's very responsive. And if I put it into, why is this range so small? Let's just do this manually. All right, so it's in the middle. And if I try to push this, it takes quite a bit of force. I can push it, and the further I push it away, it tries to go back even harder. But it's a bit too stiff. Like, I kind of wanted to, I don't know, actually, I mean, looking at this now, that's actually not too bad. But I feel like I would want it to absorb a bit more than that. Or just, I think I just triggered an error. Yes, I did. But yeah, I want to, whoops. This is another thing that I don't like about this, is that if I click the wrong button, it does some other different thing. Okay. Yes. So let's try what I was thinking before. We can get rid of the integrated gain. We can get rid of the velocity gain, make that 0. Now we only have position gain. So now this should be like a spring. If I push it, it should bounce back. But for some reason, it just keeps going up. I can push it all the way down, and now it's a bit stuck, but then it just goes the whole way to the very top. Like, its set point, you can see that red line is like here. This is where I've told it to be, but it just tries to just go up. And keep in mind, this is position gain 18, velocity gain 0, integrated gain 0. Let's make this 0.001. We now go back to where we were before, and it behaves similar to what it did before. It's just a different value, so it's a little bit different. But now, I make this vel gain 0 to what it was like 15 seconds ago, and now it's not doing anything. Now it's just loose. It's just floppy. Why, before 10 seconds ago, I had literally the exact same settings, and it was trying to go to the right to the top. But now, it's not doing anything. It's like it's off. Like, what? And this has made it very hard to figure out what sort of settings I need, because every time I do it, it's like path dependent. Like, the way the settings that I use affects, like, the way that I get to the settings that I'm using somehow affects the way that those settings behave. Why? So I'm very confused. It's very weird. I don't know what's going on there. And it's making it really difficult to vibe what these values should be. You need the velocity loop gains for the position loop to work. Do you though? Because the position loop is just this. Right? And like if my velocity feed forward is, like if my gain, no, the gain wouldn't affect, yeah, no, the position loop should be fine. Like if I have the position gain value, this is non-zero. I don't see why the velocity integrated gain, which is down here, I don't know. I evidently am not understanding this fully, but it's very confusing nonetheless. Yeah, very strange things. And yeah, this is kind of related to all of this, and more related than I wanted to be, are my misadventures with my testing rig. So you might be wondering, hang on, you, Harrison, have made this testing rig, and you showed the CAD before, and you hid all of the O-drive bits. There's evidently an O-drive in there now, which there is. Why am I not using the O-drive? Sorry, why am I not using this testing rig to do these tests like the one that I just showed then? Why am I doing this on the actual physical robot? Well, astute viewer, the reason for that is the following. So yeah, I wanted to make a test rig so that I wouldn't damage the actual robot while I'm doing this testing, because I want to be fairly aggressive with this testing rig, like really throwing the balls in and like pushing, like trying a whole bunch of different values here just to see what happens. And so that, like, for example, if the hand shoots up to the top for some unknown reason, like it did a minute ago, if it does that very aggressively, I want that to happen on the testing rig before it happens on the actual physical robot, because it's going to be way more annoying to fix it on the robot. So I wanted a testing rig so I didn't damage Jugglebot. I've added the O-drive as I showed before, and stupidly, I didn't think it would be that important to have the string routed up, down to the hand, and then the same string around the other side. So I only have it set up so that the O-drive can pull the hand up. It can't pull the hand back down again. And as soon as I strung this up, I realized that this is important because the string otherwise just gets tangled up. This sort of system where you have a motor controlling, like particularly like the motor controlling like a linear drive with these strings, as soon as that string tension is lost, that string that wraps around the drum is then free to unwrap and then wrap around something else. And it just makes so much uncertainty. So because I have on my testing rig, the O drive can only pull the hand up. If it starts to move to like lower the hand back down again, just with gravity, and the hand doesn't move, then that string just unwinds and becomes like a loose mess and is very able to and willing to get tangled on other things. And yeah, that kind of made it really annoying to use my testing rig for this. And so then I figured like, okay, well, I don't want to spend more time on the testing rig. Why don't I just use Jugglebot itself? Because like Jugglebot is set up to do exactly what I want to do. So why don't I just use that? I'm like, yeah, all right, cool, I'll do that. And now, because I had some errors come up where the hand smashed into the top a bit too fast, the motor spool is unscrewing itself, which is very, very annoying. So to show you what this means, in our CAD here, we've got 10 copies now. Woohoo! 3 likes. Very cool, very cool. The link for this CAD is in the description if you want to see it. Here is the motor on the back of the hand. This drives this spool, and that's what makes the string go up and down, which then allows the hand to go up and down. What's happening is that when the hand smashes into the top, as it is sometimes wont to do, the motor keeps going for whatever reason, because it thinks that it's supposed to keep going, but then the spool can't move any further. The spool is fixed to the string for all intents and purposes. That, wherever the string goes, the spool goes. And because the string can't go any further, but the motor is like, well, hey, I want to keep on moving, it's just unscrewing itself in here. So if I make a cut here, actually I think I can just, yeah, so this is just like a hole in the 3D printed part that the screw from the motor is just screwed into. And annoyingly, this is in the direction of if the hand is at the top and the motor keeps spinning, that will just unscrew. And what the end result of this, if it goes on for long enough, which it has a few times, this spool just moves. I can't actually move it because it's all mated in place, but from this view, it just moves out to the right and very quickly fills up this small little like 1 millimeter air gap we've got in here, and will just jam itself into the side of this printed part, completely jamming the whole thing. The only way that I can fix this that I've found so far is to get behind there with my little spanner thing that John made, which is so good. I'm starting to realize how useful custom jigs are, and this is one of the first ones that I've had such love with. So this like hooks in really nicely to the motor so that I can hold the motor still while I screw this spool back in. And of course, the more times that this happens, the more those threads become worn in and the more prone it is to happening in the future, which is super annoying. You know, this is the whole reason why I wanted to have a testing rig in the first place. I do think like I think there is a pretty solid argument for the fact that like if this is happening now, then this will probably have happened in the future anyway. So maybe the fact that I'm using this, maybe the fact that I've encountered this problem now is not such a bad thing, because I was going to at some point, but it doesn't make it any less annoying. This means that what I'm probably going to do is just leave it how it is for now and just hope that it doesn't start happening when it's just trying to like operate in normal conditions. And I'm just going to really try to not have it ram into the end. But yeah, the long-term solution, the medium-term solution, I think, is to reprint the spool and restring the whole thing, which is going to be kind of annoying. But then the long-term solution, I think, is to get this part made of metal and Loctite it in there, so it's not going anywhere. I have considered adding a, what are they called? Adding a lock nut rather, into this part, so that way that lock nut will like really hold it tight. But I mean, as you can see, there's not a whole lot of clearance in here. Like there's not enough space for a whole extra nut to fit in. And I think if I printed this with a spot for a nut, then I think that the wall thickness of this part around that nut would be very, very thin. I could potentially add a threaded insert, but I don't know how I would add an insert like all the way up here. It'd have to be like in this region. I don't know how I would get it that far in. Yeah. Yes, lots of options. I think metal is the way to go in the long term, but yeah, that's going to be annoying. A bit of waiting time. John says, if it's only happening in a crash, that's not a problem. I've not had mine loosen up during pretty aggressive throws and catches. Yeah, I'm worried that because it's loosened up a bit now, it's more prone to having this happen. Like, I'm actually pretty sure that last time I was tightening this up, I think I might have tightened it up a bit too far, and I think I might have stripped some of the threads in the spool, which is not good. Yeah, so eventually, at some point, this is just going to be like a cylinder on a cylinder, and it's just going to spin freely. So hopefully it holds on for long enough for me to get this testing done so that I only have to restring it once. But yes, no, I agree that it's perhaps time for an aluminium spool. Yes. Oh, that's it. Cool. Okay. That was a pretty long stream for the first one of the year. I don't think there's much else. There's always lots of little problems. I'm trying to show off the failures, maybe not, the unexpected outcomes a bit more. Last year, I definitely had a lot of investigations and explorations into different things that didn't really amount to much, that I never ended up showing on the streams or anything. So I'm trying to show off my failures a bit more, so that it's a bit more, I don't know, clear about how, I don't know, frustrating some of this stuff can be, and just like, it's not all cruisy, easy sailing. But yeah, so I think I've got them all for this week, but we'll see. Anyway, I'm pretty sure that's it. I hope you found this interesting. As always, there's so much stuff going on, and it can be a little bit tricky to figure out exactly what is the most worthwhile thing to spend my time on. But I do feel that getting this catch working in a compliant way so that we don't need to do velocity matching, I really feel that that's super, super important. I think that this is going to require the synergy, I guess, between the hand design. So like the way that the design is actually sent, the way that the design is actually, the way that the hand is actually designed will make a huge difference with this. We want a hand that will tolerate some amount of error in where the ball is coming in, and that's super important. If that's not the case, then catching is going to be really hard. If we're trying to do velocity matching and it is as sensitive to timing as the previous approach was, I also don't think that's going to work, because that's just too reliant on the timing being spot on. I really, really want the hand to just be able to catch the ball smoothly. It has to be able to catch it smoothly. My hope, one thought that I've had along these lines is that something that I've noticed with the particular setup of the hand is that if I have my gains set up in a particular way that it's not super, super stiff, if I have the hand, like say up here, and I tell it to go like down here, if the gains are loose enough, then it doesn't actually go by itself. It can't like overcome the friction of it staying at the top. But if I gave it like a little touch, then it will go the whole way down. And I'm thinking that maybe there'll be some way to like lock the hand at the top, just like with a very, very sensitive trigger almost. But then it actually wants to go like all the way down here. As soon as the ball comes in and like overcomes that trigger, then it can start to move towards its actual goal. Maybe, I don't know. But in any event, I want the catch to be as passive as possible. It would be so, so good if we can just tell the robot, hey, the ball is coming in over here, and then it can just move over like in line with so it like intersects the path of the ball, and then it will just automatically, passively catch the ball. That, if we can get that working, that would be such a big milestone for this project, because it means that we only need to worry about that positioning and then the throws. And the throws, honestly, are looking pretty accurate so far. Like it was accurate enough to do 2 balls in one hand, but it's just the catching just wasn't there in the past. Yep. I feel like spending time getting this catching working is possibly the best use of my time right now, but definitely a good use of my time. But yeah, so I also need to improve my logging, well, like get more familiar with the logging. I want to get the logging set up so that I have all of my logs, like all of everything that I'm using to create this. I want to have all of this up on like Google Drive or something, so that if anyone watching wants to do any analysis of any of the sessions that I've had, they can just open it up on Google Drive. I think that'd be super neat. Yeah, there's a lot of things going on. But hopefully we can get the catch to be passive and smooth soon. That'd be very cool. Anyway, yeah, Biohazard says, see you Biohazard. I'll be sure to send you a link on my finished Lego gun. Yes, I'm very, very keen to see that. Cool. Okay, hope you found that interesting. Good luck with everything you're doing, and I'm fairly sure I will see you next week. Until then, have a good one.